Imagine the thunderous roar of twin turboshaft engines cutting through the silence of the sky. This is the indomitable Chinook helicopter, a beast of the skies. With its distinctive tandem rotors churning the air, it's a sight that captures the imagination and commands respect. A marvel of engineering, the Chinook is an impressive machine. It's larger than many of its counterparts, yet its performance is nothing short of extraordinary. The sheer power of this aircraft enables it to carry out a variety of tasks, both in military and civilian operations. From transporting troops and supplies in challenging terrains to performing daring rescue missions, the Chinook has proven to be a reliable workhorse. It's even capable of heavy lift tasks, often carrying loads that other helicopters simply cannot manage. Yet, for all its prowess, the Chinook is not invincible. It's a complex machine with its own unique set of challenges. The Chinook, a marvel of aviation yet not without its own Achilles heel. Among the many things a Chinook can do, there is one that it mustn't: the forbidden maneuver. This enigmatic term, shrouded in a veil of danger and mystery, is a subject of much intrigue among aviation enthusiasts and professional pilots alike. A moniker given to a particular flight pattern, so perilous, so treacherous, it's been deemed forbidden. But what exactly is this forbidden maneuver? Well, patience, dear listener, we'll get to that. For now, let's consider the implications of forbidden. In aviation, a field where precision and safety are paramount, to forbid a maneuver is no light matter. It suggests an inherent risk, a potential catastrophe waiting to unfold. A dance with the devil, if you will, that could cost precious lives. To understand the forbidden maneuver, we must first delve into the dynamics of the Chinook's flight. Join me as we embark on this fascinating journey into the heart of aviation mystery. The Chinook's unique design is key to its capabilities, but also its limitations. Now, to understand the mechanics of this beast, let's delve into the heart of its design, the twin rotors. Unlike conventional helicopters, the Chinook employs two turboshaft engines to power two counter-rotating rotors. The synchronization of these rotors is crucial to the Chinook's flight dynamics. The twin-rotor design sidesteps the need for a tail rotor, commonly used in conventional helicopters, to counteract the torque produced by the main rotor. Instead, the counter-rotation of the Chinook's two main rotors neutralizes the torque effect. This frees up power from the engines to be used solely for lift and propulsion, increasing the helicopter's load capacity and speed. The rotors on the Chinook work in harmony, with each rotor blade's angle of attack adjusted simultaneously to alter the lift produced. When the angle of attack increases, the blades bite more air and the helicopter rises. Conversely, when the angle of attack decreases, the helicopter descends. To move forward, the Chinook tilts its entire body, with the rear rotor producing slightly more lift than the front. This tilting action propels the helicopter forward, with the rear rotor acting as the driving force. However, maintaining stable flight in a Chinook is a delicate dance of balance. The helicopter relies on the precise coordination of the two rotors and a fine-tuned balance of forces. Any substantial imbalance can lead to a loss of control, making the Chinook's flight dynamics a complex art of equilibrium. Moreover, the high degree of mechanical complexity and the need for precise control mean that piloting a Chinook is no simple task. The pilot must constantly monitor and adjust the helicopter's balance, making minute changes to the rotor's angle of attack and the helicopter's pitch to maintain stable flight. It's in this delicate balance of forces where the forbidden maneuver finds its origin. This maneuver, which we will discuss in the next scene, pushes the Chinook's design and the skills of its pilot to their very limits. Now let's unveil the forbidden maneuver, the rear rotor stall. In the world of aviation, there are a handful of maneuvers that are considered taboo, and for the mighty Chinook helicopter, the rear rotor stall is one of them. This audacious trick of aerodynamics involves an intricate dance of physics that can leave even the most seasoned pilots with their hearts in their mouths. The first step in executing the forbidden maneuver is to gain some serious altitude. Once sufficiently high in the sky, the pilot pitches the helicopter's nose down at a steep angle. The Chinook, owing to its tandem rotor design, responds to this action by increasing the rotational speed of the front rotor while decreasing that of the rear rotor. This results in an imbalance in the lift generated by the two rotors. The front rotor, spinning faster, produces more lift than the rear rotor, causing the helicopter to tilt forward even more. It's a dangerous tightrope walk, a delicate balance between maintaining control and succumbing to the forces of gravity and momentum. At high speeds, the rear rotor can completely stall, meaning it generates no lift at all. This is the crux of the forbidden maneuver. The helicopter, in essence, is flying on the strength of one rotor, an act akin to trying to balance on a tightrope while juggling flaming torches. This imbalance in lift, if not corrected promptly, can cause the helicopter to enter a dangerous spiral descent, a situation that is extremely difficult to recover from. The Chinook, with its massive size and weight, is not designed to handle such extreme maneuvers. It's a game of Russian roulette, where the stakes are incredibly high. The forbidden maneuver is not a trick to be performed by the faint of heart. It requires a deep understanding of the Chinook's mechanics, an iron will, and an uncanny ability to remain calm under extreme pressure. It's a risky dance with gravity and momentum, one that can lead to disastrous consequences. Why is the forbidden maneuver so dangerous? Let's explore. Picture the Chinook, a beast of the skies, defying gravity with its dual rotors, each spinning in sync, a testament to human ingenuity. Now imagine it attempting the forbidden maneuver, a move shrouded in danger and intrigue. The forbidden maneuver, while impressive, is a high-risk move that pushes the Chinook and its crew to their limits. It involves a rapid change in direction, forcing the helicopter to battle against the very laws of physics it so masterfully exploits. To understand the danger, we must first grasp the essence of helicopter flight. A helicopter, like the Chinook, relies on the lift generated by its rotors to stay aloft. These spinning blades create a delicate equilibrium, a balance that the forbidden maneuver disrupts with alarming consequences. As the Chinook embarks on this perilous journey, the sudden shift in motion can cause an imbalance in the rotor system. One rotor may struggle to maintain lift while the other overcompensates. This imbalance can lead to a dangerous phenomenon known as dissymmetry of lift, where one side of the helicopter generates more lift than the other. The result? The Chinook begins to spin out of control, its once steady flight path now a chaotic spiral. The pilot's control over the helicopter diminishes, and the risk of a catastrophic crash increases exponentially. But the danger isn't confined to the skies. The spinning helicopter can pose a significant threat to anyone or anything on the ground. The Chinook, a behemoth of steel and technology, could transform into an uncontrolled missile, causing extensive damage and potential loss of life. The forbidden maneuver is more than a reckless act. It's a test of the Chinook's limits and a gamble with the lives of its crew. It exemplifies the fine line between daring and disaster, a line that pilots must tread with utmost caution. In the world of aviation, there's a thin line between bravado and recklessness. The forbidden maneuver straddles this line, making it a move only attempted by those willing to risk it all. It's a perilous act, one that tests the very limits of the Chinook and its crew. So what have we learned about the forbidden maneuver? Well, it's a maneuver that's so audacious it's been dubbed forbidden for the Chinook, a helicopter known as the Beast of the Skies. The forbidden maneuver is a daring maneuver that pushes the Chinook and its pilots to their absolute limits. It's an extreme flight pattern that involves a swift, steep ascent followed by an abrupt nose-first descent. Performing the forbidden maneuver demands not only exceptional piloting skills, but also a thorough understanding of the Chinook's unique mechanics. The Chinook's tandem rotor design, which gives it exceptional lifting power and stability, also limits its maneuverability in certain ways. The forbidden maneuver exploits these limitations, pushing the Chinook into an aerodynamic situation that it was not designed to handle. The dangers of the forbidden maneuver are real and significant. The extreme forces exerted on the Chinook during this maneuver can lead to a catastrophic loss of control. This is due to the Chinook's unique rotor design, which, while providing remarkable lifting power, also makes the helicopter susceptible to a condition known as mast bumping. This is when the main rotor mast comes into contact with the rotor hub, which can result in a disastrous mechanical failure. Additionally, the high-speed nose-first descent of the forbidden maneuver places enormous strain on the Chinook's front rotor. If the front rotor were to fail during this maneuver, the helicopter could potentially flip over, leading to a catastrophic crash. In conclusion, the forbidden maneuver is a stark example of how even the most powerful machines have their limits. It serves as a reminder to all of us that the laws of physics are unforgiving, and respect for these laws is crucial for the safe operation of any aircraft. The forbidden maneuver, a stark reminder that even the most powerful aircraft are governed by the unforgiving laws of physics.